The motor effect. The motor effect is due to a force acting on a current-carrying conductor in a magnetic field. They turn electrical energy into mechanical energy. Motors are a key part of our everyday lives as they are in many appliances from power tools to hair dryers. In this video, we are going to look at how to build a DC motor, what their motor effect is, and how the components work together to create a motor in order for you to enhance your understanding of the motor effect. As this is an experiment, let's first talk about how to perform this experiment safely and minimize risks. Power tools are used in this experiment, so care must be taken to fully understand how they work. Care must also be taken when using the hot glue gun or solder to prevent burns. Do not touch the motor while it is running, as moving parts could cause injuries as well as electric shock from live wires. Finally, the magnets are very strong, and so be careful with them as they can crush your skin and cause injury. Materials required for this experiment are 15mm PVC piping cut into 130mm lengths, 2 PVC 15mm couplings, 2 small brackets, 25mm diameter radial timber cut into a 45mm length, 2 strong magnets, 91mm diameter by 3mm coaster, 2 100mm by 4.5mm flathead nails, 2 80mm screws, 2 50mm PVC DWV floor flanges, 2 150mm by 30mm by 0.25mm copper pieces, 4 20mm by 45mm by 0.1mm copper pieces, 2 M6 galvanized hex nuts, 2 300mm by 184mm by 19mm wood pieces, 1 195mm by 184mm by 19mm wood piece, 4 15mm screws, 0.8mm by 100 grams of enamel-coated copper wire, a power pack, and 2 alligator clips. Tools required for this experiment are glue, preferably a hot glue gun, solder tool and solder, saw, a drill with the 3.5mm and a 5mm drill piece, a screwdriver, a marker, strong scissors, and sandpaper. Task for the teacher. Deep cuts are made dividing into equal quarters. Finally, 4 more 5mm deep cuts are made 4mm to the right of the original 4 cuts. Method for building. Mark out the center of the coaster on both sides. Place the floor pipe on the coaster, make sure it is centered, and trace the outline. Glue both the floor pipe and the nail to the coaster. Repeat on the other side. You may want to use a cup to allow it to sit flat. Place one of the large rectangular wood pieces and lay it flat. Take a smaller rectangular wood piece and stand it upright 70mm from the back of the bottom of the wood piece. Place a bracket on and trace. Drill the pilot holes and put the screws in. Take one of the 4 thin pieces of copper sheet and slide it into one of the slits. Press down, flattening it across the large section. Slide it in through the other slit and then slot it back in its first gap and pressing back towards the new side. Repeat this for the other 3 pieces. Glue the pieces into place by removing the creases, putting glue in the cuts and replacing the pieces. Ensure all excess glue is removed as the surface must remain smooth and even. On the base, glue the nuts 120 mm from the front and in the centre, and repeat for the top piece. From the front right corner, mark a point that is 40 mm from the front and 30 mm from the edge. Place one of the couplings centered over this and trace. Repeat for the other side. Glue the couplings down into place. Next, wrap 40 turns of wire around the piping and coaster, keeping the wires as close together as possible and leaving 50 mm facing up at either end. Repeat at 90 degrees to the original turns. Sand the commutator copper and the ends of the coil wire. Place the commutator onto the axis on the same size as the wires are sticking up. Taking the thicker piece of copper, leaving 20 mm on one side, glue the thicker copper sheet into the slit in the PVC piping. Repeat for the other pipe. On the top piece of wood, mark 80 mm from the back and 20 mm from the side. Make sure that the nut is on the opposite side and repeat for the other edge. Screw the long screws in at these points so that they can just be seen coming out the other side. Place on top of the vertical piece of wood and screw down into place. This may require pilot holes first before screwing. Cut 2 300 mm lengths of copper wire. Sand the ends and solder the ends on the back of the 2 mm of one of the brushes. Repeat for the other brush. Solder the wires of the coils to the commutator. Very carefully lift up the front of the motor and slot the axis between the 2 nuts. Slightly curve the ends of the brushes inward. Slot them into the coupling and rotate inwards so they are up against the commutator. To run the motor, connect the power pack and wires to one positive to one brush and the other negative to the other brush. Turn on the power. Hold the magnets on either side of the coils so it creates a strong magnetic field. The motor will now spin. Why does the motor spin and how do we know which way it'll go? There are 2 key points about magnetic field lines that cause the motor effect. The first is that magnetic field lines always move from north to south, and the second is that magnetic field lines can never cross or touch. As we know, a wire carrying a current produces its own magnetic field, and we can see this using the right-hand grip rule. As we are placing the current-carrying wire in a magnetic field that is perpendicular to the wire is going to be pushed away so the magnetic field lines don't touch. And we can work out how it is going to be pushed by the right-hand rule. For the right-hand push rule, you must use your right hand. Your fingers go in the direction of the magnetic field and your thumb in the current. Then you're to push your hand forward from that position. That is where the force will go. So in this instance, our magnetic field lines are going from right to left and our current is coming up into the wire, which means we're going to experience a force out of the page and the motor will spin towards us. If we look at it from the other side, the current is now going down in this side, but the magnetic field lines are still going the same direction. This means that the force will be pushed away from us, and so the left edge of the motor will spin towards the back. This produces the motion of the motor. And now you understand how the motor effect works.